Okay, still on solubility problems. You will look at that question. If you can do it, you do it. If you cannot, just write solution. Write solution. Why you wait? Okay, by now you should tell me the answer. Yes. Answer is what? Okay. Well, answer is what? Okay. Since we're on solubility, let's see the solution. First of all, molar mass of K2CrO4 is given as what? 194 points what? 2. Is that clear? Then mass of K2CrO4 is what? Let it be our X. Okay? Let it be our X or unknown. Question what? Mark. Okay? I use question what? Mark. And then solubility in MYDREAMSACADEMY is what? 0.020. And then volume of solvents is what? 250. Okay. So using solubility equals to what? Mass of K2CrO4 over molar mass of K2CrO4 times 1000 centimeter cube of solvents over volume of solvents. Okay, now when you plug this whole out, so you have that solubility substitute it as well. 0.020 is equals to what? That is mass of K2CrO4 over what? 194.2 times what? 1000 over what? 250. One thousand over 250 is what? 0.020 is equals to what? Mass of K2CrO4 times what? 4 over what? 194.2. You cross multiply. So what do you have now? Or you make this the same formula, you have what? Mass of K2CrO4 is equals to what? 0.020 times 194.2 over 4. Answer is what? 0.971. To two significant figure is what? 0.97 what? Answer is what? And no of crystallization can't do it together. Okay, that is it. This hall is noisy. Okay. Other one. Okay. Make sure you are participating in this class. Make sure. Yes. Yes. See another solubility program. Potassium triacylchloride 5 has a solubility of 1.5 mol per dmq at 45 degree Celsius temperature. And then on cooling the solution to a temperature of 20. The solubility was found to be 0.5. What is the mass of KClO3 that was crystallized out? Answer is 1. Answer is 1. That is the pure case of this one. Okay. Have you seen where you solve solubility problem 2 times? You solve at different temperatures. But one thing you must understand here is that since they say that the solubility of these salts at this temperature was 1.5 mol per dmq, what does it mean? It means that the volume that dissolved this 1.5 is 1 dmq, yeah? Or 1000, isn't it? What is molar concentration? Amount of solids in 1 dmq or 1000. Any solution. So what we do is, first of all, write this. What is the molar mass of salt? Molar mass of salt. Which salt is that? KClO3 is what? 39 plus 35.5 plus 40 what? 8. You know how we got 48? You know how we got it? 16 molar mass of atom of oxygen times the number of oxygen KClO3, which is what? 122.5. That is the answer. But that is not the answer. I will show you that I will arrive at that answer, but it will vary. Okay, now let's go. What else am I writing here? Solubility, Abi? Solubility, I have 2 solubilities. So solubility at what? 45 degrees Celsius is what? 1.5. Abi? Okay. Mass of KClO3 at 45 degrees is what? Let me use X. Is what? X. What else? Okay. Since, for instance, 1.5 mol per dmq, which means that the actual volume of this molarity is 1000. So we can use volume of solvent 1000 or 1 dmq if you choose to. Or there's another formula you can even solve it. Since you have solubility, you have molar mass, you find mass. So what do I do? I will say, with all of this, I will say solubility in mol per dmq. And there solubility in mol per dmq, since actually volume is both solvent and volume is the same. Solubility is equal to what? Mass of salt over what? Molar mass. It is another formula to solve solubility. Plug in what you have. What is solubility mol per dmq here? 1.5 is equal to what is mass there? X over what? 122.5. Because what? Multiply. Are you with me now? So what you have here, this is what? X equals to what? 1.5 times 122.5 is what? 188. Okay? 183.75 what? Gram. At which temperature? At what? This temperature. Yeah? So we calm down. You run this thing again at different temperature. So we now can say, okay, the mass still remains the same up here. Mass is still so, and I say, hence, I come to the next one. Hence, solubility at what? On cooling, which is what? 20 degrees Celsius is what? 0.5 up here. Good. Then mass of this thing remains the same. So mass of KClO3 is what? 1.5. Abia? No. Is what? Mass of this. Okay. Mass of this at that temperature unknown at 20 degrees is what? X. Is second X. Okay? At this temperature. But molar mass of salt will go here. Molar mass of KClO3 is 122.5. Therefore, solubility at that temperature, solubility is what? Mass over what? Molar mass. So what do we do again now? We put up these things we have here. 0.5 equals to x over what? 122.5 equals multiply. Abi? So what is x now? X is 0.5 times 122.5. X now is what? 61 point what? 2 what? 5 what? Gram. They now ask us to find the mass that was crystallized. Now, if you want to know the mass, the highest temperature when it was high minus what? Lower temperature. The higher temperature, and I say therefore, mass of salt crystallized out is what? 183.75 minus what? 61.25. Answer is what? I think I got the answer. I think I was joking. But if you didn't get like that, another question, that is something. You may vary. Yes. Yes. No, now. Ask me something. No, now. Here I took a eating. This kind of solids at 45, this amount will dissolve. This thing now, at 45, this happened at 45, and the solubility was 1.5, and the mass of salt was this, at high temperature. Then I have to cool temperature got to what? 20. It means that now, at 20 what cool will go now? Mass got dissolved that is lesser. That is how we got 61.25 at much lower temperature. So what it tries to say that solubility increases with increase in what? Temperature. Just same as the mass of salt or potassium from the solubility. What about the mass of salt at high temperature minus mass of salt at low temperature? If you do it like that, you now have negative there. You can have solubility mass of salt in negative one. How do we go through that reverse exercise? If you like, you can solve it in mass. Those times you can do that. Without even wasting time, you can do it. Actually. You can even use solubility formula to solve it. That formula. The only thing you will do there, you can still use this formula. Solubility equals to what? Mass of what? Solutes over what? Molar mass times what? 1000 cm3 over what? Volume. But one may ask me, what the volume was not given? Who told you that? It says solubility is 1.5 mole per dmq. 1 per dmq, what does it mean? 1 per 1000. So if you put it solubility here, we're getting 1.5 equals to mass of solubility is what? X. Over molar mass, 122.5 times 1000 cm3 over what? 1000. If you ever the short is now. If you short here, we'll stay here. X now is what? X is what? This times this. You get what? This. So whichever we want to do. What volume of this is needed to do this, do that, do that. Okay. Want to check? Yeah, check that. Okay. Should I claim? Okay. What volume? What volume? Okay. I think we've solved something like this before. I think I've solved it now. What volume? You are not there now. You've not got the lesson that day. And I repeated something. What volume of 0.1 mole of acid which has what volume of which specific acid? So now see, there's no need to solve this thing. Use the same formula. What are you looking? Which parameter are you looking for here? Just take this and find substitute volume. Find the answer. Something below. Because the solubility is what? 0.1. Abi? The mass of the salt. What is the mass of the salt? 2.86. What is the mass of the salt? Look at the salt here. We find relative what? Molecular what? Mass, which will give you what? Something like this, but it will be what? 2, 8 what? 6. Find the answer. Find the volume. Or should we do it? Should we do it? I think I told you what to do. Solubility is what? 0.1 equals to mass of salt 2.86 over 2.86 mass of this thing, okay? Times 1000 over what? Volume. That volume is what you are looking for. Is that it? Since you're using 1000 here, okay, your answer will be in centimeter what? Cube. Is that it? So what do you do? Simple. This divided by this what? 0.1 equals to what? 0.01. Abi? What you have here? Yes. Times what? Times what? 1000. Abi? Over what? Over what? I think over volume. Over what? Volume. I think. Then find your answer. Answer is what? Make volume solid formula before you answer. How do you test 0.1? 0.1 is the molarity now. Where is it? Where is it? Where is it here? What volume of this? That is the solubility now. Okay, 0.01. What is mass over molar mass now? Mass over molar mass, 0.01. I think that is the mass of salt over molar mass. That is this times this. Then find it. So answer is what? 100 centimeter what? Cube. But the problem is now, if you are giving such solubility, please take note. Now, if an A and the 2, the acid is what is 0.1, not the base. Not the what? Base. Acid, what volume is needed to dissolve this? Not this. So, but why are we using 0.1 as that molarity of this? Is the equation. You have to balance the equation to know if the mole of this is same thing with this. So if the mole is 1:1, that means the molarity of this and this is what? 0.1. Assuming they give you this and this base, maybe sodium hydroxide. Let me change it to sodium hydroxide. So you know now. You know that the mole ratio of this is now what? Is 2 here. Molarity will now double for this man. So the molarity will be 0.1. This is what? 0.2. So what will you put here? 0.2 for this sodium hydroxide. Are you following? I would like to solve it this way. But I was so clear that I wasn't even getting the answer. That was my problem. Let me see if I can get the answer now. Use CV equals to what? N. Abi? Now, you know that the concentration. Okay, first of all, before we continue, let's see the reaction. H2SO4 plus Na2CO3 plus what? 10H2O. What is going to come out here? Na2SO4 is changing Abi plus what? H2O 11 Abi. Because we have 10 times 2, 20 plus 2. So 22 Abi. So what is going on here? CO2. Mole ratio is 1:1 Abi. 1:what? 1. So it means that 1 mole will give 1 mole. Abi? What is the mole of the acid? 0.1 of the acid will give you what? X. So if you do this is what? X is this times is 0.1. So basically 0.1 of what? Na2CO3. This is concentration of this. That is your what? Your C. You find V. But before you find V, you must know what? N. Okay. Sorry. I know you say. This is your what? This is number of what? Mole. What is concentration? Concentration now is this over what? Molar mass. Which apparently is what? 0. What? 0. What? Wait, let me take out this volume. What volume of this? So apparently this is concentration. This is now number of what? Moles. So let's see. So this thing we have now is already given here, which is concentration. So plug it in here. 0.1 times what? V equals to number of moles is what? 0.01. Okay? This time is what? 0.1 V equals to what? 0.01. Divide both sides of there. By rule. And you don't need 1,000 again. You convert to 1,000. So you divide it, but leave it like this. What will we add here? 0.1, 0.1. So what is V now? Is what? 0.1. 0.1. So this 0.1 is 0.1 what? DMQ. How do you convert now? Let's say if 1 DMQ will do 1,000, then 0.1 will do what? X because multiply. That is what? 100. Thank you. Hi. Jesus. Only that I got as a textbook. I do last question on computer. Question very star. Talk and work and free. How could this guy teach us Solubility curve? Okay, I now know. Solubility curve is coming. It's ready. You're wasting my time. There's one solubility problem before I go to solubility core. That will be the last on this topic. We want us to teach you non-metals, at least chlorine and phosphorus. I cannot solve all these questions you're giving me here. I will solve just very few. This one is very simple. Please, when you don't do here, mark okay. This one is kind of what mass of chlorine can be formed by the position of 64 of which of the following reaction. Oh, wow. But let's do it now. Can't do it tougher. Take this question down, please. Let me see the best hand here. Right. What mass of chlorine? What mass of chlorine? What mass of chlorine can be formed by decomposition what mass of chlorine can be formed by decomposition of 64.0 gram? What mass of chlorine can be formed by decomposition of 64.0 gram of AlCl3? What mass of chlorine will be formed can be formed by the composition of 64.0 gram of AuCl3. AU, good. Oh, yeah, info. AuCl3. Nine. What is that? AuC. I'm going to use the computer here. I'm going to look at it. I'm going to say I'm look at it. You got figure. AuCl3 by the following reaction. Okay. By the composition of A. The equation is given. A 2AuCl3 2AU plus Cl2 then 3. That's again by the following reaction. So this is the reaction. The answer is what? The individual that copied this one is very simple. We cannot be going back. Actually, now solve a little bit more challenging. 16.55 of lead 2 nitrate was dissolved in 100 grams of distilled water. At 40 degrees, calculate the solubility of solids. It can't be simple now. It can't be very powerful. Are you there? When you send the monka, I am a monka. You know, if they get a question, did you tell any? The question 90 Ologodo, and then on water of crystallization. The mass of possible. Mass of gold. I don't even know. That's the problem. I don't even know. Mass of gold. Okay, I think it's 193. Eh? 109. I can't be 109 now. Mass number is where they are 193. One motion. Somebody should check now. Check your phone and tell us the molar mass. Ordinarily, when such questions are given, you should give us the idea of molar mass. Nobody should carry molar mass on our idea. So 197. So I'm kind of cool. So AU 197. Ndị na-achọ m ya bụ ndị chọrọ ịlụ ya. Ndị mgba nkịtị bụ ndị na-achọrọ ịlụ ya. Okay, what is the question again? Okay, what would they say we should find out here? Mass of gold up here. Mass of chlorine up here. How many moles of this reacting? How many of these is also decompose? Mass of this decompose 60. Okay, 64. What is simple now? How many moles of this decompose? 2 moles. Okay? I will decompose into how many moles of chlorine? 3 moles. Then I answer that go afterwards. Maybe. 1 mole of every substance is same as the molar mass. Okay? That was why people asked me molar mass of gold. So what is the molar mass of 1 mole of gold? You say gold indicator is 90, 197 plus 35.5 times 3. So we need that again. 4. But 2 more, 1 more. I want to go to 1 more. Molar mass of AuCl3 is what? Put the question. Please get it. We want to find the mass of AuCl3. The mass of this by summing the atomic masses. Atomic mass of gold is what? 197. So you add 197 with the mass of chlorine. Chlorine is 35.5, 35 times 3. Nobody will add there with what? 197. So what does it give me? Over 6 is 2 moles that we have here, multiplied by 2. But that means 2 moles of this is equivalent to what? 6 what? Or what? 7. You can't be sorted out. Then therefore, 3 moles of this. Check it. Can take a look at the 1 chlorine molecule like this is what? 35.5. Okay? All the 2. But I say by 71. What do you call it? 3 times 71 by 3. What do you mean? 2 what? 3 up here. 213 up here. That means, what does the 2 more decompose now? In mass, 607 decompose to give you what? 213 grams of what? Chlorine up here. I'll link here. If you know there's ammonia now. Then, how many will? What was the mass of this? How many will 64.0 decompose into X? You crucify. This is what? 607x equals to what? 64.0 times 213. Okay? So 607x is equal to what now here? Now process so 136 what? 3 what? Wait, 1362. Another 3, another 2. That's 136,032. Whatever. What do you do now? Divide both sides. By who? 607, 607. X what is what now? Only? Oh yes, one question now. Can I come on now? Or no, the question. But because we have a jump question. That size what? 20 what? 22 point what? 4 what? You can say 22 point what? 5 what? Gram. That was the mass of chlorine obtained by decomposing what? The salt. Now, solubility products of body. Before solubility curve. Number 2. Chimo. Yeah. I don't die. Hold this one. I take it there far and blow it. Hold it. Somebody give me that similar thing. I got it. You do me again. Officer. All right. Okay. Now take this one down. 2.5 grams of hydrated barium salts. You know here? 2.5 grams of a hydrated barium salt. 2.5 grams of a hydrated barium salt gave on heating 2.5 grams of a hydrated barium salt gave on heating 2.13 grams gave on heating 2.13 grams of anhydrous salt gave on heating 2.13 grams of anhydrous salt. Full stop. Given that relative molecular mass, use RMN, one of the shorts. Given that the RMN of anhydrous salt is 208. Given that the relative molecular mass of anhydrous salt is 208, comma, the number of molecules of water, yeah, that's the line. That's it done. If you go from there. But go. You can go. Don't come back. The number of molecules of water of crystallization. The number of molecules of water of crystallization of the barium salt is dash. That is the question. I want answer. Or I will give it to you as assignment. If I say now take it as assignment, you say, hey, yeah, I want to dodge it, you don't want to solve it. If I solve it, what if I solve it? It doesn't make difference. If I solve it, majority of you will not still understand. Yeah. Answer is what? Somebody will go there and answer. But to tell us not two, will tell you na first question. How do you show all workers? Let me see your working. Who gave it to? Now? Give me the give me where you solve it. You just you go the first question. You just ask. Or if you will be if now look at two. The answer is 2. Well, let's go to the next question. Okay, now when you are given such kind of problem, you see hydrated, you see anhydrous. How many things have you seen? 2 things. Salt with water, salt without water. Use this formula. Mass. All the cap. Solubility formula, but it's not for this formula. Use this formula. Mass of what? Hydrated salt over molar mass of hydrated. You know here now. That equals to mass of what? Anhydrous. Okay? Over what? Molar mass of anhydrous. Now what's the question? What is the mass of hydrated there? Is your question? Come on there. 2.5 over. What is the molar mass of hydrated? What is the molar mass of the barium salt? Molar mass of the barium salt. 208. The hydrated will not contain the milliampere. So that was 208 plus. The mass of H2O is what? 18. So we are looking for number of H2O there. So we'll now put N. Are you with me? Or use X for what? Unknown. Equals to what is mass of anhydrous? What are you? What is hydrated? Salt with water here. Then the question gives you molar mass, liquid molecular mass of what? Barium salt without water. So molar mass of barium salt is what? Check now. RMM of the salt is what? 208 ampere. What is the molar mass of hydrated barium salt? 208. You add water. But the water you are adding, you don't know the amount of water you are adding. So as I said, water is H2O. What is the relative molecular mass of water? It's not what I just added there, 18, but I don't know amount. I don't put what? X. Equals to what is the mass of anhydrous? Is what? 2 point what? 1. 1 give me. Now put the name correct figure. 1, 3. Oh, but what is the molar mass of anhydrous? 2 or what? 8. Cross multiply. Like this. 2.13. Go to the end. Because what? We multiply with what? 208 plus what? 18x. You are done. Equals to 2.5 times what? 208. Are you there? Make it just equal cross multiply now. Increase not on worrying now. But when we come 2.13 times 208, before you 4, 3.04. Is that clear? Plus Nka times Nka 28 point what? 34 what? X equals to Nka times Nka 5 3 2.5 times Nka 5 2 what? 0. What do we do at this point? Collect, okay? We collect. You will collect. Collect this. Say 38.34x is equal to what? Is what? 443.04 minus what? Wait, let me think. What are you telling me? Is what? 520 minus 443.04. But let's go here. 38.34x is what? 76 point what? Now what? 96, Abi? But divide. What are we dividing with? Both side by what? 3834. 3834. So x alone here is what? Is what? The nearest whole number answer is what? 2. Is it 2? It's 2. Yes. Keep your way now. You want to show me something, say show me all workings that time. You do not show me. You just go to the answer and say it's 2. It's a chance pass. It has passed. Okay. Okay, that is it for that. Solubility products. Solubility products. In brackets, KSP. Are you there? Are you there? Okay. Now right. Now right. Right. A salt, a salt, a salt, a salt will precipitate, will precipitate, will precipitate or crystallize, will precipitate or crystallize, will precipitate or crystallize from its solution, from its solution, from its solution, from its solution. If the ionic products, if the ionic products solubility, if the ionic product solubility, if the ionic product solubility is greater than KSP, is greater than KSP, is greater than KSP. That is solubility constant products. That is solubility constant products. Solubility constant what? Products. Solubility constant what? Products. Full stop. Now look at this. Is this a soluble or insoluble salt? Is it soluble, Abi? So how will this salt dissociate or ionize in solution? Is ionized into what? Ag plus what? Cl what? Minus. Is that clear? That means, what is the KSP of this? KSP is what? Only products of this dissociation. So if you want to write KSP for the other, so KSP is what? Concentration of what? Ag plus inside times what? Cl what? Minus. I'll put it like this. Or I can put it this way. This solubility which we don't know, we can use what? X. Solubility of this which we don't know is what? X. I can say or KSP is what? Since we don't know the solubility product of these ions, I can say that here is what? X. How many moles of H ion is here? 1. Raised to the power 1. Okay? And what? This what? X. Raised to the power what? 1. Or I can say that KSP is what? Is what? X squared. These are questions you are not asking. I think why I decided to teach this particular solubility topic, I think I saw up to 3 or 4 questions on this particular topic, this particular salt. Let me give you one. Take me sit down. Let's just do 1 or 2. Then we go to solubility curve. Okay, are we there? Are we there? There? Now write this question down. 1997. A saturated solution of AgCl. A saturated solution of AgCl. A saturated solution of AgCl. AgCl was found to have a concentration of 1.30 times 10 to the power minus 5. Was found to have a concentration of 1.30. Concentration of 1.30. 1.30 times 10 to the power minus 5 mole per dm cube. 1.30 times 10 to the power minus 5 mole per dm cube, comma, the solubility product of HgCl, the solubility product of HgCl, the solubility product of HgCl, the solubility product of HgCl is therefore dash. Is therefore dash. Go to option A. Right. 1.30 times 10 to the power minus 5. 1.30 times 10 to the power minus 5 mole per dm cube. 1.30 times 10 to the power minus 5 mole per dm cube. B. 1.30 times 10 to the power minus 7 mole per dm cube. 1.30 times 10 to the power minus 7 mole per dm cube. 1.30 times 10 to the power minus 7 mole per dm cube. C. 1.69 times 10 to the power minus 10. 1.69 times 10 to the power minus 10 mole per dm cube. 1.69 times 10 to the power minus 10 mole per dm cube. And then D. 2.60 times 10 to the power minus 12 mole per dm cube. The thing is that what in this analysis, what are you asked to find in that question? Is it KSP or X? Check the question. What are you looking for? What is X? X is solubility of this product up here. This is KSP. So the question says you find what? KSP. So we are giving what? X. So once you set up this thing, what do? You then say KSP. I'm solving, I'm continue solving from here. So now say KSP is what is the solubility of these two here? Is given as what? 1.30 times 6 by what? Minus 5, you now what? Square. That is the answer. So check if it is correct. What's the answer there? Answer is what? 1.6 what? 9 times 6 by what? Minus 10 up here. Mole per what? dm cube. That is the answer. Okay. There's another one. There's another one. That one probably. Now take it down if you're there. You can have a pick. Because there you can now. Well, there's time. At least we have 30 minutes. Do you want to go by 201? Go by 201. So what's leaving here by 6? That's if we have. It's now some of you don't even know what. You just be roaming about aimlessly. The solubility product of CuiO3 bracket 2. The solubility products, the solubility products of Cu bracket IO3 bracket 2 on the board. The solubility products of Cu there on board bracket IO3 bracket 2 maybe copper 2 trioxoiodide 5 is 1.08 times 10 to the power minus 7. Is 1.08 times 10 to the power minus 7. Is 1.08 times 10 to the power minus 7. Full stop. Assuming that, assuming that neither or neither ions react appreciably with water. Assuming that neither ions react appreciably, just write APPRECIABLY, appreciably with water, to form H plus and OH minus. Assuming that neither ions react appreciably with water to form H plus and OH minus, comma, what is the solubility of the salts? I'll repeat. The solubility product of CuiO3 2 brackets is 108 times 10 power minus 7. Assuming that neither ions react appreciably with water to form H plus and OH minus, what is the solubility of the salts? Options are too big for me. Let's solve it and tell me the answer. Anyone with correct answer? 100 naira gram. First, magic finger, the first person to announce the answer. And they will show me what you saw. Okay, I'm going to add pure water to it. Code 1. Code 1. Code 1. Is it 1 point? Where is the question? It is not in the option. Nothing like that resembles the option. Option 2.7 times 10 to the power minus 8. 9.0 times 10 to the power minus 8. 3.0 times 10 to the power minus 3. 9.0 times 10 to the power minus 3. Okay, 2.7 times 10 to the power minus 8. 9.0 times 10 to the power minus 8. 3.0 times 10 to the power minus 3. 9.0 times 10 to the power minus 3. Answer. How does this thing differentiate? Let's start with it. See what? 2 plus, Abi? Plus what? 2 IO3 minus. So how do you write KSP for this? KSP is what? What goes in here? Cu 2 plus, then what? IO3 minus with the what? 2. If you want to solve, set this thing up like this. KSP is what? What is the solubility of this copper? X. What is the power of what? 1. What is the solubility of this thing? Is 2x. What is the power of what? 2. If you don't do it that way, you won't get the answer. So what do you do now? See what you do. This square is what? Is what? Is 4, isn't it? Which is what? 4, yeah? This square is what? 4. 4 give me 4s give me. I want to know. Is it 4s squared or 4s cubed? 4s squared or cube? It's cube now. This, square this and this is going to be what? Cube. This is equal to what? KSP. Check the question. Let's see what we are looking for. Is it KSP or X? Check the question again. Check it. What is for KSP? Or KSP for X? Is X. I'm not sure. Let me check the question again. Now, solubility products of this is this. They give us KSP. We are looking for X. Do you understand it? You see, solubility product, the solubility product is KSP now, which is given as what? Please help me with that figure. 1.1. Please help me with that. 1.08 times so power minus what? That's what? 7 equals to what? 4x what? Cube. You know what to do now? X cube is what? 1.08 times 10 to the power minus 7 divided by what? 4. What is x cube now? The only can divide and can one answer. Then you cube your answer. The only answer can give 2.7 times 10 to the power what? Minus what? Open an option. Open an option. But the chief is you can see x equals to what? Cube 2.7 times 10 to the power minus what? 8. The real x is what now? Check it now. Are you sure it's 1.6? 1.6 is not the option. Answer is what? 3. Check it again. So answer here, bring this in here. X is what? 3.0 times 10 to the power minus what? Are you sure it's minus 8? Minus what? 3. Is it the option? I can check the option. How do they do? Check the way. You don't understand? If you come out in jam, you feel it's just only work with one question. Options say 2.7 times 10 to the power minus 8. B. 9.0 times 10 to the power minus 8. C. 3.0 times 10 to the power minus 3. D. 9.0 times 10 to the power minus 3. So which was correct? 3.0 times 10 to the power minus 3. Just pray that this kind of figures does not come out. So to be a figure that lists ordinary adding calculator machine, let it not be, let this, we pray that let it not reach the extent of keeping it. Okay? But when we make a square roots, it will know square roots. I thought the square root now that's adding machine. But remember, question I can answer for now for 1999. How can you use the calculator now? Right? Open now, you get computer. You know how can person a cube square. So they don't enter cube. They stop at square. But just know how to run it. But when we use it around mathematics, you do it. All mathematics you use it. Alright. Okay. Okay, try this one. What is that BiI3? What is BiI3? We have heard about the element called bismuth. That's bismuth iodide. So the element of bismuth iodide is this. Calculate the soluble product of the salts. Answer. Yes. Yes. Are we finished? The answer is what? Yes, yes, yes. 24. Command number, if you're going to have 1 point. 8 points. Times 3 square. We're going to 0.0000 or the standard form. Okay, now meanwhile, now listen. The first thing you will do, because ionize. You don't know what to do to ionize? How am I going to write ion of bismuth? Bismuth is what? Is oil with 3. So it is bismuth what? 3 plus. Plus, only I don't know, 3 ion minus. You do it in a way that the sum of the charges of both ions is 0. You check it down, it's 0. This is the first. So you now set up the extract, KSP. What is KSP? How do you write the KSP? KSP is only for product. You don't write the salt. Write only product. That's why it's called product solubility. Product or solubility constant. Here, which is equal to what? Concentration of what? Bismuth. How many moles of bismuth do we have here? 1. It doesn't need to raise it to power. So how many iodide do you have here? 3. So write I minus, you now raise to what? 3. Are you with me now? So which if you want to solve, you say KSP is equals to this solubility of this. Take it to the word X, which has no stoichiometry. You just write what? 1. This is what? How many X's? 3 X's. Raised to the power of what? 3. And then what do you have now? That KSP is what? Cello. That was 9. So the possibility here is it 9? I think it's 27. Let's check more. 3. Jesus. Jesus Christ. Is what? 27 what? X. S getting. S what? X what? 4. What are you looking for? As I said, I only product of this. You are not looking for S. You were giving what? S. Are you with me? You are not looking for X. What is X? Let X ever. Wait, what do you say? I only product of this. What is the product of this? This times this. Are you with me now? So the X is known. We will now have to find what? The KSP. Calculate what? Solubility what? Product. KSP. So leave your KSP here. Say KSP is what? 27. What is X? X is what? 1.4 times 10 to the minus what? 6. Then what? Is it cube or this? You now put what? But you know this kind of question. So what you see here is 0. So what is my answer here? KSP is what? There you go, man. You look at time set on the now. Take up million scientific calculator. What answer will you give me? Okay, 2.0 times 2 per what? Minus what? Minus what? 18 or 8? 18. What is the unit for KSP there? Mole per what? DLP. As period. Period. The most important thing is to know whether they ask you. Now, if they say, what is ionic products? We are actually looking for solubility of the ions. Okay? For instance, what is ionic product of this? We are looking for solubility of this. What is KSP of this? We are looking for what? This. Constant. This is constant. This is what? Solubility what? Product. So this question now says you should find X, but they will not tell you find X. They will not ask you to find what? Ionic what? Product. So they say, look in the ionic product of water. If it has such solubility, that means you're looking for what? H plus and what? Or H what? Minus. Like I said, this question normally comes out once in a while. Once in a while. It has not come out in the last 7 years down. But 10 years now. So you expect it to come out. Then, Ochipota. Then can I put a result? AGCL. Remember that link. Because I can't link here to 12. We only just say AG plus what? CL minus. Well, even now, how many solubilities is there? Is what? X squared. Check is here. Open any of the X to find KSP. Open any of the KSP to find what? S. Like your boss will this way. I think I have to control it.